linear equations again, but this time linear inequalities, and we're talking about two variables as opposed to a single variable. When we talk about two variables, we'll still talk about x and y. We need to think of them basically as equations with a different sign. So the only way to solve a linear equation is to actually graph it, or the best way to solve it is to actually graph it. This will help us visualize what the linear equation will look like. Basically, for example, if we start with 3x plus 2y is less than or equal to 6. I'm just choosing less than or equal to randomly. We will need to start thinking about this as an equality. Our first step is to convert the inequality into an equality. So this becomes, you'll have to think of it as 3x plus 2y equals to 6. Now the fact that we have an equality on the bottom bit, so it's less than or equal to, that means the line will be solid, is solid, as opposed to it being dotted. What we're going to do, we're going to graph this line. We'll use the table of values, just as we did with graphing lines, x and y. When x is 0, I just basically cover the x. That means 2y is equal to 6, so that makes my y equals to 6 over 2, which is 3. When y is 0, in this case I'm covering the y, I'll have 3x equals to 6. That means my 3x, my x is equal to 6 divided by 3, which is just 2. So my two intercepts are 0, 3. This is my y-intercept. This is where the line will cut the y-axis. And my x-intercept is 2, 0. X-intercept. To graph the line, I simply plot, put in the 2 points. This is my x-axis, and this will be my y-axis. So this is x, this is y, and this is the origin, as usual. Basically, I'm just going to go by squares. This will be 1, 2, 3, 4. So I have 0, 3, and 2, 0. 0, 3 would be 1, 2, 3 right here. This is my point 0, 3. 2, 0 would be 1, 2. This is my 2, 0. And I simply connect the two dots by a line. Now, what I need to do is I need to figure out which side to shade. I will have to choose an arbitrary point. An arbitrary point is a point that is not on the line. Any point that is not on the line. In this case, in our case right here, we can always choose 0, 0 because the line does not pass through 0, 0. If it did pass through 0, 0, we could not choose it. We'll have to choose another point. I will choose 0, 0 because it is the easiest point that I can choose. So I will check the inequality with 0.00. I will substitute this value in my inequality. It was 3 times x plus 2 times y less than or equal to 6. That means 0 is less than or equal to 6. This relation right here is true. I will shade the true side. I will just simply shade everything that is I'll basically shade everything that is on this side of the line. The line, we have to keep in mind, is infinite. It has no ending, no starting point. So it will cut the plane, this whole thing right here, it will cut it in two different parts. This line right here has cut it into two different parts. One side will be true, one side will be false. Now what happens if we have an in-between relationship? If we had an in-between relationship, or if we had a simple line that is not less than or equal to, that's just simply less than. If it was 3x plus 2y, I'm just going to use the same equation to simplify my work, is less than 6. The same line, same exact line, but this time it will not be solid. It will not be a solid line, it will be a dotted line. This is my x, this will be my y, this will be 1, 2. This is 0, 3, again. This is 2, 0. So I will dot a line. I will create a dotted line, not a solid line. Not that. A dotted line that will pass. That means that the line is not part of the relation. The only solution in blue will be the shaded part. It is the same inequality, only in this case it is just shaded. Now if my inequality had, instead of a less than or equal to, had an unequal sign, basically I will have to remove the shading, because everything is a solution except for the line itself. Let's try to graph a line where we have an in-between relationship. Simply, let's say I have the minus 2 less than x less than or equal to 5. This is a straightforward relation. Again, x-axis, y-axis, y-axis. I will have, let's say this is minus 1, and this is minus 2, 1, 2, 3, 4, 5. The line that is in between minus 2 and 5, I'll have a vertical line going through minus 2, but in this case, because I have an inequality that does not have an equal sign, there is no equal sign on the bottom bit, there will be a vertical line right here at minus 2, and it is dotted all the way up and all the way down. Like I said, it goes on forever. I will have a solid line going through 5. A solid line going through 5 will go as such. Not that kind of solid line. Let's hope for a more reliable solid line. There you go. So it is solid at 5 because 5 has an equal sign with its inequality. it is dotted at -2 because there is no equal sign. And the solution is in between the two. The solution is in between the two. Therefore, I don't need to test it. I can simply shade in between, because this is where the truth side lies. Just in between -2 and 5.